We're going to be considering
just cycle and
N-hydroxypiperidine this
the
time. So, as I said, the name N-hydroxypiperidine, and we look at the structure right here, we find that the IUPAC name is one piperidine, or you can say piperidine one, or and some people also call it one hydroxypiperidine. Then, if we look at the structure, we see that it has the similarity to cyclohexane, which is then connected to an hydroxyl group. So we also look at the formula C5H11NO, then the weight, which is about 101.15 grams per mole. If we also go back to the structure one more time, we see that there are no degrees of unsaturation except the rings. So no double bond, no triple bond, just the ring. This also means that all the carbons are sp3 hybridized. So one, two, three, four, five. So they're all sp3 hybridized. And there are about 18 sigma bonds in this molecule. We have one, two, three, four, five, six, seven, eight right here between the oxygen and hydrogen. Then we also have about 10 hydrogens around this ring. So that plus 10 would be 18. And there are no pi bonds because there are no double or triple bonds, which means that the electron density diagram will be even, except at the top where oxygen is taking the electrons. Then, like I said, the functional groups are N-hydroxy and it's a secondary amine because it's there. The nitrogen is connected to one carbon here, then the hydroxy group on the top. And then its melting point is between 37 to 39 degrees, and it's a solid at room temperature. 37 to 39 degrees is about like body temperature. So basically, if you held N-hydroxypiperidine in your palm, it would melt right there. And looking at the structure once again, we see that the unique carbon sets amount to three because there's a plane of symmetry right here. So this would be one, two, three. And since there's a mirror plane right here, this and this and this and this are all the same. And since that means we have three unique carbons. And at the same time, we also have four unique hydrogen sets because we would have one right here. We would have two hydrogens right here. So that would be a set. Two hydrogens right here. So that's another set. Two hydrogens right here. That's another set. And since there's a plane in between, we it's multiplied over to this side when we're counting the hydrogens. So this would be one, two, three, then the one on top, four. So if we're counting the hydrogen set ratio, it will be four because two right here. So that's four hydrogen, two right here, four hydrogens again. So four, four, two, then one. That's why we have this right here. So we also have three lone pairs in the total as well because one on nitrogen and two on oxygen. Then if we look at the classifications of the carbons present, most of them are secondary, and this means they are methynes. So that's a CH2. And yes. Okay, so we're gonna be building N-hydroxypiperidine with the Snatoms kit. So with the Snatoms kit, we see that black is carbon, Black is carbon, red is oxygen, blue is nitrogen, and white is hydrogen. These are the ones we need for N-hydroxypiperidine since it has the structure of cyclohexane, which is cyclic, and it has a molecular formula of C5H11NO. So we're going to take the carbons, then we build it. Since we need 5 carbons, and then there's a nitrogen right in between in the ring itself. So we're gonna do this. Then we need 1 oxygen for the hydroxyl group and 1 hydrogen for the hydroxyl group. Then we simply add the remaining hydrogens. Yes. So like I said before, you see that's the conformation of cyclohexane. So we can twist it around to have the boat or the chair conformation.
So we can twist it like this for the bowl, then for the chair. But yeah, and we also see that since it's cyclic, like I said before, it has only 1 degree of unsaturation.